So welcome to this morning presentation on AP and GP. I want to enlighten you more on what you can do when you're confronted with a question from arithmetic progression standpoint or from geometric progression standpoint. So from arithmetic progression, as it goes, you know it is a type of progression where terms differ from each other by a fixed number we call common difference. So in other words, to get the common difference, you take the succeeding number, you subtract the preceding number, and that number is the common difference. So if you see a progression of that type or a progression that obeys that kind of thing, we call it arithmetic progression. And in arithmetic progression, you also have sequences and series. So we have arithmetic series, arithmetic progression. The difference between the two is that for sequence, it is quick to understand that you have terms separated by commas, and for a series then you have to talk of finite number of terms added. So the most conspicuous feature of a series is you'll see them having a plus sign between terms. That's what can tell you whether you're dealing with series or a sequence. Okay, so it's very important also to talk about how you can get the number of terms when you're given the sequence. Maybe it can be difficult if you start counting 1, 2, 3, 4, or even when somebody asks you what is the nth term of this sequence. I think it's a bit logic for someone to count like you have a million terms and you want to literally count 1, 2, 3 up to million. That's a very difficult and cumbersome exercise. So which is why a formula, a relation is very important. So in this case, I want to give you a relation on how you can obtain the nth term of a sequence or a series, and in this case, arithmetic progression. So nth term is obtained by taking the first term, then you add into bracket n minus 1 times the common difference. I repeat, you take the first term plus into bracket n minus 1 times d, where n is the number of terms and d is the common difference. Okay, so if you want to get the sum of terms of a given progression, in this case arithmetic progression, whether series or sequence, you take sum of n terms is given by n over 2 into bracket 2 times the first term plus n minus 1 times d, close the bracket. That is when you know the number of terms and you have the first term, and you can also establish the common difference from the given sequence or series. We have another situation or another case where you can be given the first term and the last term, and you know the number of terms. You use sum of n terms is given by n over 2 into bracket first plus last. I want to point out that in most cases the number of terms is not obvious to know, because when you're given the first term and the last term and nobody has given you you have been given, let's say, the first 2 terms and the last term. So the first and the second term are there to help you to get the common difference, because it's just a matter of subtracting the preceding from the succeeding term. And you have to assume that the nth term of that given series or sequence is equals to the last term. So that last term is what you are going to assume it is your nth term, so that once you get the number of terms that constitute that given sequence or series, you can use then that n in the formula that I've just given you for the sum, which is sum of n terms given by that n over 2 into brackets a plus l, which is first plus last terms. So that's what you do for arithmetic progression. I will tell you something that is not obvious. Arithmetic mean is achieved by taking a plus b divided by 2. That's what we call arithmetic mean. And what is it? Arithmetic mean is that number which, when placed between two terms, they form arithmetic progression. So you're given me, let's say, two terms like 2 and 4. Which number can be placed in between the two and they form arithmetic progression? The answer is you add 2 to 4. Then you divide by 2, you get a 3. And actually you'll have 2, 3, 4. That in itself, it's an arithmetic progression, because if you take 3 subtract 2, you get a 1. If you take 4 subtract 3, you get a 1. So you have a common difference. In a situation where you have a common difference, we call that one arithmetic progression. Allow me to now go to geometric progression. Now, geometric progression is a kind of different from arithmetic progression, because instead of terms which are consecutive, differing from each other by a common difference, they differ by a constant ratio or common ratio denoted by little r. Now, to get this little r, which we are calling a constant ratio, you take the succeeding term and divide by the preceding term, which will give you a ratio. We call it common ratio. This common ratio is a very distinctive feature of a geometric progression. So geometric progression is achieved by taking a preceding term and multiplying by a fixed number constant to get the succeeding number. Alright, so if you want to get the number of terms, you take, if you want to get the nth term, I should say, you take a, the first term, times common ratio or constant term, if you like, raised to the power of number of terms in question minus 1. So that is the only way you can get the nth term of a given geometric sequence or series. If you want to determine the sum of n terms, we have two handy formulae, and the choice of the two formulae will depend on whether the modulus of the common ratio is either bigger than 1 or less than 1. Now, what happens when the modulus of common ratio is bigger than 1? We use this formula for sum of n terms as n, a into bracket, r to the power of n minus 1, close the bracket, then divide by r minus 1. I come again. Sum of n terms when modulus of r is bigger than 1. You take a, the first term, open the bracket, take common ratio to the power of number of terms minus 1. Close the bracket, divide by r minus 1. If you have the modulus of common ratio less than 1, say s is equals to a, open the bracket, 1 minus common ratio to the power of number of terms, close the bracket, divide by 1 minus r. I repeat, if you have modulus of r less than 1, take first term, open the bracket, 1 minus common ratio to the power of n, close the bracket, over 1 minus r. So why geometric progression? Because terms differ from each other by a fixed number. We call it common ratio or constant ratio. So constant ratio is attained by dividing the succeeding number by a preceding number. I give you an example. You can have 2, 4, 8, 16, 32, 64, 128. That's a simple type of geometric progression. So if you want to get the common ratio, you have 2, 4, 8. So you can, to get the common ratio, take 4 divided by 2, you get a 2 again, which is similar to 8 divided by 4, which is a 2. So whichever two terms you pick that are consecutive, the succeeding divide the preceding will give you a ratio, common ratio, which will help you now to obtain other components that you want to determine. Now, geometric mean is that number which, when placed between two numbers or two terms, they will form a geometric progression. For example, you have numbers like, let's say, 2 and 4. Which number which, when placed between these two numbers, will form a geometric progression? The answer is you take 2 times 4 square root. 2 times 4, you square root the product, and you're going to get square root of 8. So that is the number which, when placed between 2 and 4, the numbers will form a geometric progression. We'll discuss more on this when we shall be dealing with the practical examples. I haven't spoken about the harmonic mean and harmonic progression, but it has got a very close connection to the arithmetic progression, but in our next video we'll discuss more on that. So I'll stop there, but in my next video I'll help you to compute problems when you are asked something to do with arithmetic progression and geometric progression. Thank you.